Hello and welcome to the third episode of the Daily Data Science series. And I'm very excited to have you here. Hope you're all enjoying and having a great day. So in today's session, we are going to understand the term data science in a lot of detail, right? What do we mean by science in data science? And then we are going to go into what do we mean by the data part of data science. You must have heard about buzzwords like artificial intelligence, machine learning, and so on, and also terms like big data. So we'll try to understand very specifically what these terms actually mean. So without further ado, let's get started. All right. So what is the science of data science? Firstly, we will come to what is machine learning. And machine learning is a very popular term, and a lot of people are not aware of what machine learning is just because the term is so different, right? So if you talk about data science, it's very easy to understand that you are doing something with data and it's related to science, right? So you are having some structured way of thinking to solve the problem of getting insights from data. But what do we mean by machine learning, and specifically what is machine and what exactly is it learning? Now, let's define this formally. Machine learning is an approach to automating repeated decisions that involve all algorithmically finding patterns in data and using these to make recipes that deal correctly with brand new data. Right? Let me make it very simple. If, as a baby, I show you, right? If I show a baby different images of a particular object, like a car, right? Like a toy car, for example, or like a toy airplane, right? He or she will be able to understand that, okay, this object is similar, right? If I'm showing a toy car every time, then it will be very obvious to the baby that, all of these are toy cars. So he or she is classifying, that category of objects as a toy car automatically. What we are doing in machine learning is what we are inputting to the system or the algorithm is a lot of images of toy cars, and we are labeling that, okay, this object is a toy car, this object is a toy airplane, this object is an actual truck, and so on. And it is automatically understanding the distinct features of that object and being able to classify into that particular category, right? So it's kind of learning. That's where the learning part of machine learning comes in. Why we are saying is automating repeated decisions. So repeated decisions in our example is basically classifying the object, right? And how is it doing that, right? How is the system or the algorithm actually doing that? It is finding patterns in the data, right? So when it is looking at images, it's probably looking at certain distinct features, right? What characterize that particular object as a particular class or category. So it's finding patterns in data. This will become very easy to understand if you're thinking about tabular data, right? We have taken an example of an image, but if you think about tabular data, this kind of a concept becomes much easier, right? You have a person who clearly stands out as a person who, is more likely to do a default on a loan, right? Based on his or her history of, let's say, different credits that he or she has taken, right? How many times have they defaulted on a loan, right? What is the delinquency rate, and so on. Right? So looking at all of that data, you have the target that, okay, this person is likely to default, this other person is not likely to default because probably they have a strong score, right? So the system actually learns like which parameters in the data actually are contributing heavily to the output, right? So it's automatically algorithmically finding patterns, and then it is using these patterns to make recipes that deal correctly with brand new data, right? And this is where the power and the magic of machine learning comes. It not only learns the patterns, it is able to generalize well into the future, right? So if you input, right, a new image, right? Let's say you have bought a very fancy toy car for your kid from the US, right? And it's different in a lot of features. Now, machine learning ideally should be able to recognize that, okay, although it is different in a lot of features, it's still a toy car, right? Similarly, if you're analyzing the data of a new person who has come to your bank, right, and you need to decide whether to give him or her a loan, you need to understand and use machine learning to be able to predict that. So it has to be able to generalize to brand new data. There are two main things that we have talked about. First is finding patterns, and the second one is the ability to generalize well to brand new data. And the approach that we have largely talked about is kind of an approach where we're just feeding it inputs and outputs and expecting it to learn the relationships, right? We are not defining the relationships directly. And that is where machine learning is different from a rule-based engine, right? A rule-based engine would be that, if these parameters have these values, then do this, right? So it's complete rule-based. But we're not always able to create rules, because real world systems are not that easy to game, right? If it were easy, everyone would start gaming it and getting the better out of it. But they're not so easy. So you need to resort to machine learning in cases where you have a lot of data and you have a lot of parameters and you're trying to understand latent relationships in the data. Now, when should you not use machine learning and not throw it at every use case that comes out? If in theory or in concept there is no pattern which is connecting the inputs to the outputs, right? If you're trying to predict, let's say, the temperature, right? If your temperature on a particular summer day with respect to the sales of ice creams in a particular city, right? Although they may be very, very highly correlated, right? They may be correlated is that, whenever ice cream sales are going up, the temperature is also going up, right? There can be that correlation, and there generally is. But you cannot use ice cream sales to predict the temperature, right? Because that doesn't make sense. Although there is a correlation in the data, but it doesn't make sense. So in such cases, machine learning should not be used. So always make sure that you're thinking from a conceptual or a business point of view and making sure that there is a pattern that should exist, and then you are going to uncover it. And even though there is a pattern, you need to make sure that the existing conditions only slightly change or they continue to be roughly or approximately the same. For example, if you're forecasting the demand of, let's say, sanitizers, before COVID occurred, right? The sales of sanitizers would have been very, very different to compare to the period of COVID itself, because it was a complete change in the condition around the world, right? The environment completely changed. So machine learning would never have been able to predict that sanitizer sales would spike up during 2020, 2021, 2022, because the conditions themselves changed a lot. So you need to keep in mind whatever machine learning system or whatever kind of a algorithm that you've built, and you're trying to use it to predict for brand new data, right? The second part of the of what it is constituting, ability to generalize well. You need to make sure that it is able to generalize because the conditions are roughly the same. All right. So if these two conditions are satisfied, it is able to find patterns where there are patterns. It is able to generalize well where the conditions are remaining approximately the same and not changing drastically. Then machine learning is a very, very good solution for predicting. Now, what are the types of machine learning? I will just go over this quickly because we are discussing this topic, but we'll dive into this into a lot of detail in the later sessions. So what are the types of ML or machine learning, right? There is supervised machine learning, right? If you watch the video just before this, we talked about regression and classification kind of applications, right? Both of those fall under supervised machine learning. And we will decode this more, right? What do we mean exactly by the word supervised later on? Then there is something called unsupervised. This is referring to the finding patterns applications in the previous video, right? Or the previous session. Unsupervised basically means you're trying to find patterns in the data. And then there is something called reinforcement learning, right? Think of it like an agent behaving in an environment, like a robot actually behaving as where to walk, what to say, how to react, and so on. So it's kind of a reinforcement learning. Even if you think of self-driving cars, when they automatically think of, whether they should stop or whether they should speed up and so on. So they have a mind of their own where, they are performing certain actions in a particular environment, which is the traffic condition, and getting certain rewards out of it. That is, if they drive safely, they will get a reward out of it, right? So that's the field of reinforcement learning in a very, very high level. Now, machine learning is very popular as a buzzword, but not as much as something more popularly known as AI, or what is artificial intelligence. Now, let's decode this in more detail. Artificial intelligence, right, is a way that computers mimic human intelligence, right, across all domains, right? It can be tabular data processing, how we look at numbers, how do we process numbers. It can be text based, how do we read sentences, how do we speak, right? It can be vision based, how do we, see things, and so on. And how do we create new images more recently, right? Like generative AI is able to create new images, right? Like humans who can draw and so on, right? So if you give a simple prompt that I want to draw an ice cream on the landscape of, let's say, Dubai skyscrapers, right? So the generative AI machine can actually give you that image where, a person is holding an ice cream and the background is the Dubai skyscrapers, right? Similar to how a person would actually do. So AI on a high level is intelligence, which is mimicking human intelligence and performing complex tasks. Now, how is it different from machine learning? Basically, artificial intelligence is a very, very broad term. It is encompassing many fields like machine learning, deep learning, and so on, right? And it has a very, very big overlap with the term data science as well. So traditionally, what we can say is data science encompasses AI, and data science also has other things, right? There are not AI. It has statistical analysis like causal inference and so on, right? But it does have this field of AI where you're learning from the data. So data science is the overall field. Then we have AI, right, which is a more specific field, and within that we have machine learning and deep learning and so on, right? Deep learning is just a subset of machine learning, right? So deep learning is basically saying being able to process images, process text, and so on, right? So if you think of applications like self-driving cars, where the car is actually seeing the objects, it's computer vision. It's also a part of deep learning. And if you think about text-based applications like Alexa, right? It is also deep learning. It's part of natural language processing. So this is the entire field of AI, right? And AI ML is a term which we will often find on job postings, and even in your organization, whenever you're talking about data science, you're talking about AI ML, right? And you should be aware that AI ML is simply another term for data science. So if someone's saying I want to do AI ML, they are just saying I want to do data science, right? So be very, very clear on this terminology. Now, what are the types of AI? Did you also know that there are types of artificial intelligence? Let's walk through these. There is something called artificial narrow intelligence. Intelligence which is artificial and which is able to perform well on specific tasks that it is trained on. Things like self-driving cars, where they are trained on identifying objects in front of them. Applications like Alexa, which are trained on hearing, processing the speech to text, right? Understanding the text, responding, and then giving a speech back, right? It's a very, very specific task. So this is called artificial narrow intelligence. Then there is something called artificial general intelligence. Like humans have general intelligence, right? Like to train a AI engine to actually recognize objects, right, in front of it, it will need to look at a lot of data. But a baby can do it with only a few images, right? So that's a general intelligence that humans have. They can pick up things very, very quickly, right, which machines cannot. And there is general intelligence across many other things, right? So artificial general intelligence basically means that an AI is able to generalize and perform a wide variety of tasks, even though it is not trained on it. And then there is something called artificial super intelligence, which is intelligence which is superior to what humans have. And obviously, we have not reached artificial super intelligence yet, right? Even artificial general intelligence we have not yet reached. So both of these applications are artificial narrow intelligence, and there was an interesting news article recently, right, concerning OpenAI, where artificial general intelligence was discussed. So it was rumored that OpenAI is working. Let me open this link up. OpenAI is working on its system called QStar, right? And this was leaked by the company, right, or by someone within the company, that this is a step towards artificial general intelligence. But I have read a lot of reviews by experts, right, in the field, and what they have said is this is mostly a hype. We are nowhere close to artificial general intelligence. The reason being, artificial narrow intelligence, right, the ability to perform well on very specific tasks, it is also not yet very matured, right? So we still have to really, hit the ball out of the park for artificial narrow intelligence, right? And then we can think about something called artificial general intelligence. Okay, so this was concerning the science part of data science, where we talked about what is machine learning, right? What are the two parts of machine learning, which is its ability to find patterns algorithmically from the data, right? Whatever the data might be, and its ability to generalize well on brand new data, right? And we talked about certain types of machine learning. Then we came to AI, where we defined what is artificial intelligence. It's a general term encompassing a lot of fields, which basically deals with mimicking human intelligence. And we talked about a few applications as well as different types of AI. Now, what we are going to do is we are going to shift gears and talk about the data part of data science. And specifically, we'll talk about what is this term called big data, right? And this is very often confused with data science, right? Let's understand what is meant by this term called big data, right? What is so big about it, right? What do you define as big, right? And data, does it mean any data, right? And so on. So, formally speaking, right, there are generally three parameters on which we define a data to be big data, right? The traditional parameters are the first three: volume, right, variety, and velocity, right? And then these three other V's have been added recently. So volume is the first one, the amount of data, right, that you are gathering. How huge is it? If it is huge, then it is one step forward into defining the data as big data. The variety of the data, right? What are the types of the data that are present, right? Is it structured? Is it semi-structured? Is it unstructured, right? There are different types of data that can be there, right? So the variety also defines another vertical of big data. And then there is velocity. How often are you getting the data, right? How quickly is it coming? The speed at which big data is generated, this is another vertical of defining big data. The other three verticals are veracity. How easily can we trust the data? How trustworthy it is? Value is the fifth one, which is what is the business value of the data collected? Is it of any value or is it just random noise, right? That also matters. Otherwise, it's not useful at all. And what's the variability in the data, right? How can it be used? What are the use cases can it be used for? How can it be formatted, and so on? All right. So this is where we defined big data, right? And there is no clear cut point that you would say that, okay, any data which is more than these many GBs in size is called big data. There is no such cutoff. But generally speaking, when we think of applications like, let's look at some examples. When we look at social media, right? When you're clicking on different, friends' profiles, and you're probably sending them chat messages and probably liking on Facebook and so on. All of these are actions that you're taking, and these are being tracked by that particular social media company. That also constitutes big data, because this kind of data, first, it satisfies the volume. The variety is satisfied because let's say you're interacting with Facebook, you are clicking likes, dislikes, right? That's kind of a structured data, which can be structured, but you also type in text. So that's kind of unstructured data. Text is always unstructured data. And then there is semi-structured data where you are, doing a mix of the two. Velocity, the speed at which this kind of data is generated. Think about millions of users around the world using Facebook at the same time instant, right? So velocity is also high. Veracity, is it truthful? Is it trustworthy? It is, right? Because Facebook is ensuring that it is collected properly. Value, the business value is immense, right? Facebook has a lot of revenue coming from advertising, and they use this kind of a customer data to advertise to customers. Variability, how can it be used and formatted? There is immense value there. So this is an example of big data, right? And it satisfies the 6 V's of big data. Think about Internet of Things, right? And this is something you might not be familiar with. but let's define this, right? So Internet of Things basically is a paradigm where devices, you have devices, right? And they have sensors, they have softwares that communicate with other devices, right? So there is kind of a communication which is happening, and a lot of data is getting stored, right? Think about different fitness tracking machines or watches that you wear. Those also are part of Internet of Things, right? And there are a lot of other devices as well. You can have sensor data, you can have machine logs, and you can have a lot of data. It satisfies the volume, it satisfies the variety as well, right? Sensor data can have different kinds of structured, unstructured data. Velocity is high, right? If you have a smartwatch and you're constantly doing activities, it will basically store all of that, and it has all of these three other verticals as well, right? It is not necessary for every kind of data to have all of these, right? The main three are the first three: volume, variety, and velocity. But the general idea is it generally has all of these six, right? The reason being, right, if you think about big data, it's so huge. Variability has to be high. Value also would be generally there, right? Unless it is completely noisy data. Veracity is something which refers to how the data is getting collected, right? And how it is getting generated. So if that is the case, it will also be there. Financial transactions that you're making, let's say in your internet banking, right? Or you're doing whenever you're going to a point of sale system, right? You're going to a retail store and you're swiping out. All of these constitute big data. All right. So we covered very, very interesting topics in data science today. And we talked about what is machine learning, what is artificial intelligence. We then talked about big data, right? And I want to leave you with this thought. If you have any questions, feel free to put it in the chat, and I will respond to you as soon as possible. Hope you enjoyed the session. Stay tuned for tomorrow. See you soon.